Okay, we're recording now. And oh boy. I wanted to do a rant, or at least hopefully talk about my opinion of why I like tubes and why I feel for the best sonic result, at least in my opinion, you have to have tubes in the system. I'm not saying it's, again, and I want to say right out front, I don't know everything. I don't have all the answers. I'm a guy who's just been playing around with this hobby now for 40 years. Damn. And, yeah, you you pick up a few things that you hope are tenets that you can follow. Sometimes you're proven wrong, sometimes you're proven right. But anyway, I wanted to hopefully, you know, you may take what you want from this. You can leave it all here if you want. Doesn't matter. Anyway, what you see on the bench here is the bench. This is my dining room table. Well, what you see here is a tube preamp project that I've been playing with for the last year or two. Whenever I get frustrated, I kind of set it down. This was supposed to be my assault on the cost no object high-end tube preamp. A lot of the guys in the DIY audio forum had been raving about the 12B4A tube, which is a what is it? It's a TVIF amplifier, I believe, but it's like a mini power tube, and it feels like it. These guys get pretty damn hot, but it's supposed to be, they call it the next super tube. I heard it called that. Anyway, I said, well, I'll see what I can do. So I designed this dual mono, fully balanced uh, preamp using MOSFET plate load on it. And so far, the results have been less than what I wanted. I mean, if what you want is the sound of a single-ended triode tube amp with fairly high distortion and a deep, dark, moody sound, it's got that. But it doesn't have what I want in an amp, which is the good parts of the tube sound with a minimum of the bad parts of a tube sound. And I consider excessive THD and tubby mid-range as faults in tubes. So as you can see, I'm not going to claim tubes are perfect. I'm not going to say solid state is the device of the devil. If you've seen any of my other videos, you'll see that I have quite a farm of solid state power amps sitting behind the speakers there. It's because I feel right now the best and most cost-effective way to implement tube sound is to go with a tube preamp and a solid state power amp. Because what tubes are just marvelous voltage amplifying devices. Where they fall flat on their face is in current amplification, which is where solid state excels. So if you leave each to work where it does best, I feel you get the most cost-effective result. So again, we're talking a compromise here, and I feel that's going to be, I guess, my number one talking point here. I've got a few over here, is nothing is perfect. And, even those $10,000, $20,000 units you see in the magazines, they're not perfect. They're probably pretty damn good, but, if you're like me, you'll probably never get to hear one, let alone own one. So the way I get around that is I have some technical background, so I try and build my own gear. Things like this monstrosity. So anyway, oh God, see. So I guess we need the history lesson here. I apologize in advance, but we do have to talk about the 70s. In the 70s, you had two schools of thought, the meter readers and the golden ears. And the meter readers were the guys who looked strictly at the specs. You know, how many watts will it put out into 8 ohms? What's the distortion rating on this? What's the noise floor reading, and so on. The golden ears, in contrast, were guys, the numbers didn't mean that much to them. Or not, the numbers weren't the end all be all to them. And they were more inclined to purchase what they felt sounded the best. And these were the guys who kept audio research and Macintosh going in the 70s, where most folks were drifting to the Japanese receivers because they just had these marvelous specs. The numbers look great. I mean, and yeah, if you were going strictly by the numbers, they looked like perfect products. They looked amazing, you know, and they had, you know, a slew of features. But there was, of course, life being what it is, there was a fly in that ointment. And the Japanese manufacturers, they actually got into kind of a war between each other to see who could sell the receiver or power amplifier. Back then they were basically integrated amplifiers. Sell the one that had the lowest distortion numbers. And they'd actually compete to see how many zeros they could get after the decimal point in the distortion spec before a non-zero number appeared. So you would commonly see receivers with, you know, 0.0008% THD at full output power and all this. And, you know, that was the way it went. That's what sold the those units in the magazines back then. A lot of people would buy them mail order or whatever, so, you know, they rarely listened to these things first. They were going by the numbers. I fell into that trap. I bought a lot of Dynaco gear based on its distortion readings. I had a Stereo 400, you know, great specs, sounded terrible. So one of the things they found later is, well, let me first say, the mechanism that's usually used to lower distortion in an amplifier is negative feedback. It's where you take the output of the amplifier, turn it upside down, feed a little bit of it back into the input of the amplifier, and the amplifier will actually self-correct what distortion it's making. There are a lot of assumptions made. Let's see. That all the devices are fast enough to respond in real time to the demands that negative feedback places. Also, well, we have to go back to the fact that back then the transistor of choice was the bipolar transistor, and much of the late 60s, early 70s was spent just getting bipolar transistors to behave themselves, not go into thermal runaway and burn up, and how to make them a stable amplifier. And then once that was accomplished, then the wattage level started creeping up and up. Bipolars, I'm not going to say they're inherently nonlinear, but they have an exponential characteristics curve. And this causes them to create, it causes them to create a fairly, all their distortion harmonics. When you talk about total harmonic distortion, it's that the amplifier is making harmonics that aren't there in the original signal. And in bipolar transistors, those tend to be odd order harmonics. Now, if you stay with just third order harmonic, you get kind of a big upfront bold sound, big and brash, and a lot of people love that. It's what makes a rock band when you go hear them live sound so impressive. But when you add harmonic distortion, it doesn't just, act as a blanket and reduce all the harmonics equally. What it does is it will reduce the low order harmonics and as a trade-off generate upper order harmonics. So you may have reduced your third, fifth, seventh, and ninth order harmonics in your solid state bipolar receiver, but you've also somehow created 11th and 13th, 15th, 17th order harmonics just that have no relationship at all to the music signal. Now, admitted, they're very small level, but because they're a totally unnatural form of distortion, have no counterpart in nature, they sound very, what little there is can sound very disagreeable and add a character. You may not perceive it as distortion as much as just the thing sounding kind of sour. It's hard to explain. But anyway, also, as I mentioned before, the assumption with negative feedback is that the devices you're using are going to be quick enough to respond in time to correct the faults in the amplifier without failing at it. And the sad thing is, during the distortion wars of the 1970s, what they did is they increased the gain of the amplifiers, which meant nonlinearity probably went up, but then they'd heap on just tons, 60, 80 dB in negative feedback, whatever it may be. Probably not that much, pardon me. But they'd add all this negative feedback, and the poor device, using the slow transistors they had back then, would struggle to correct itself in time. Couldn't do it. So what it would do is it would create a phenomenon which they found out about in the late 70s, early 80s, called Transient Intermodulation Distortion, or slewing-induced distortion. And this is where the device, because it can't respond quickly enough in the time domain, it generates distortion harmonics, or actually intermodulation effects, which are even more disagreeable sounding, in the frequency spectrum. Now, intermodulation is where you have two signals, and they usually do it at like 18 and 19 kilohertz. And then they look for that one when they do a test for it, they'll inject 18, 19 kilohertz into a amplifier, and then they'll look for that 1 kilohertz difference. So there should be, if there's a distortion artifact at 17 kilohertz and at 20 kilohertz, they know they're getting intermodulation to some degree. And, this is the other thing I have to mention. See, it's always so complicated. What I think is going to be a simple subject is never simple. But most of our tests, until the late 70s, early 80s, most, if not all of our tests for quality, a quality indicator in an amplifier or preamplifier, were static state. We just generate a test signal, send it into the amplifier, and it'd be fine. And occasionally we'd send a square wave in and look at it and go, oh, well, that's an and usually the thing would just screw up the square wave horrendously, and we'd go, well, that's probably inaudible. We'll just go ahead, steady as she goes. So, but anyway, in the early 80s, they started addressing this. But anyway, I'm getting ahead of myself. So this was one of the mechanisms whereby, as they increased the negative feedback in these amplifiers, which gave them exemplary static state measurements, they started sounding worse and worse and worse. And there's some pretty nasty sounding gear in the 1970s. I will attest to that. I'll swear on whatever holy book you got. Now, oddly enough, tubes, they're fairly wide bandwidth devices, even though they have a rolled off gentle treble on a lot of them, not all of them. But they seem to be more or less immune to this function. One is they have simpler circuits. We're not trying for, 100 dB open loop or 120 dB open loop gain before we apply our 40 to 60 dB of negative feedback to them. Also, tubes on their own, you're going to yell at me for this, but a lot of the tubes, especially the older ones like the octals, I'll show you an octal tube here. We're looking at oops, just lost that, but it's not going to come out of the box, of course. But your older tubes like the octals, this is actually a preamplifier tube. It's similar to the 6SN7. But even the older tubes before that, because they didn't, negative feedback didn't come about, it wasn't really introduced until the Williamson amplifier, which was, I'm trying to remember, it was like, I think it was just after World War II, maybe 1946, 7. I could be wrong there. But before then, the tubes had to sound fairly decent on their own, and they did a fairly impressive job of designing tubes that could work in a circuit and produce less than 1 or 2% distortion without any negative feedback. Since then, we've learned a lot of new tricks. We know how to linearize tubes, and we can get the distortion well below 0.1% without negative feedback. So anyway, simple circuit without huge amounts of negative feedback tended to create a better sounding product, which is why your tubes were more successful. Let's see, how far have I deviated? I've gone into, okay, I think I'm kind of on track here. So what I want to talk about then is, you can't rely usually on the static, steady state distortion specs to accurately describe the sound of your product, of the or the amplifier receiver preamplifier you're buying. What you want to look for is the quality of the distortion, not the quantity in most cases. So I'll come back to that. But anyway, in the 1980s, they learned about slewing-induced distortion, transient intermodulation distortion, and also so they decided, there was a trend to use faster devices in the products, which meant that you could use feedback without slowing the amplifier down and creating slewing-induced distortion issues. So the quality of the distortion, not the quantity. We're not concerned about absolute values of distortion, getting it as low as possible. Low is nice, and definitely that's the starting point you want when you're designing a product. But there are other factors. We could have two amplifiers. One is one is fast, one has low distortion, but it's full of ceramic capacitors, which generate dielectric absorption, which is a type of distortion. It's another type of time-related distortion, where the dielectric material in the capacitor actually soaks up the energy from the signal going through it and then releases it over time. And it creates a harsh, raspy quality to the sound. So that's our number one amplifier. But we have a slower amplifier with measured higher distortion, but it's full. The capacitors in its signal path are all film types: polypropylene, polystyrene, perhaps even Teflon. But I will tell you that chances are, you listen to these two amps in an A/B test, you would probably choose the one that has higher distortion and better caps as the better sounding unit. So again, there's a lot, audio's a stew. There's a lot of things go into the stew, and the quality of the parts is one of them. So again, the quality of the distortion over the quantity. So my experience has been, they say that you can't hear total harmonic distortion below 1%. I'm not sure about that. If so, then it doesn't really matter, because most of your modern tube gear can easily operate below that at sane listening levels. Here's another interesting thing. When you measure tube gear, the distortion, distortion changes with the output power on any amplifier usually. And in a tube unit, usually it'll have its lowest distortion at the lower wattage levels. And if you have efficient speakers, if you're running your tube gear into a Klipsch or JBL or what's the new company? Tecton. An efficient speaker, something capable of producing 95 to 100 dB of sound with, 1 watt in, that tube amplifier isn't working very hard at all. And so it probably has distortion far lower than its rated distortion at full power. Solid state, or at least my experience with solid state, is the exact opposite. That most solid state gear has its lowest distortion at lower levels. And it's actually reduced. I think the distortion remains constant, but its proportion to the signal is, of course, reduced as the signal gets larger and larger. So solid state gear measures superlatively at full power. But when you measure it at 1 watt, it may not be, I'm not going to say it'll sound bad, but it probably will measure noticeably less than at its, the distortion would measure noticeably more at low wattage levels than it would at full power. Let's see, I think I'm still keeping up here. So as we mentioned, bipolar solid state devices generate third order harmonics, or odd order harmonics. So normally in a well-designed solid state unit, you can keep them low order. So basically third, fifth, seventh, maybe some ninth. That being done, you can usually design a fairly decent sounding power amplifier. In a preamp, because the device distortion is fairly large compared to the signal level, it's going to be a little more audible and probably a little more intrusive. This is why tubes work so well in preamps. They're marvelous voltage amplifying devices. You can basically design a circuit like this where you have an active plate load, either a tube or a MOSFET, for a triode, and easily get the THD on the triode below 0.1% distortion without trying. And the end result, without negative feedback, and the end result will actually sound quite nice.